All right, folks, Dr. Shane back here, another pre-lab video, and actually I'm making this during your first kombucha lab. Still got some students collecting some data. Dr. Kegeris is gonna be around, so we got a little action going on here, which is fine. Okay, so this is kombucha number 2, and we are determining the acid content of kombucha this time. So, yeah, so make sure you have this lab, and also there's some Excel data that I will give you for your pre-lab, which will basically be a dry run through all of the calculations. So this is probably pretty obvious, but the main challenge with this lab is going to be collecting the data in the given amount of time. It shouldn't be an issue, but as soon as you come into lab, you can see this on the left side. Get the apparatus assembled. We'll probably have one up front so you can look at it as a model. But we did titrations last semester, so I think this is a pretty familiar apparatus. I don't think I really need to go through all of this, and then you'll watch the video that Dr. Kegeris did for the pH meter. So, you know, you've got a ring stand. The pH meter is kind of the thing we didn't do. Now, last semester you did titrations, as far as I can recall, but there we didn't have a pH meter, and we just added enough of the titrant in the microburette to change a color. Well, color won't work practically with this lab because we're titrating kombucha, which already has a color to it. So that complicates matters. So we're not going to add an indicator in this case. So it makes it kind of interesting. So it's a titration, but it's different. It's a pH titration curve. One thing I want to remind you all of, this is, I don't know, it's probably easier to see this here. So here's your micro pipette, and make sure that you put one of these plastic tips on the end. So because if you forget that, then you get big, this really controls the drops. And then you take the syringe and put it at the top. And this is what your NaOH is going to go into. And as always, record the molarity of the NaOH off of the bottle. And you rinse this out and fill it up and get it on the, get the meniscus on the 0 mark and put it in the burette clamp. So this has your NaOH, fine. The other thing you can do as soon as you get into lab is measure the pH of the undiluted kombucha. And you'll see in the conclusion section that kombucha is generally around 2.5 to 3.5 pH. Okay, and I'm going to actually stand here behind the camera for a little while to show you about the pre-lab calculations. And you're just going to start off with that Excel data. So make sure you have the Excel data. Also, section 4.5 of your OpenStax textbook shows you how to do titration calculations. That'll be useful in a little bit. Okay. So for the pre-lab, what we need to do is, the first thing is to, whoa, let's see if I can show this here. So this is the data that's on an Excel spreadsheet for you, that's given to you. The first thing you want to do is make the titration curve. So that's the pH on the y-axis and the volume of the sodium hydroxide added on the x-axis. Now you'll notice those are really small volumes. Now this is actual kombucha data. You're only adding a total, in this sample data, a 0.5 milliliter to do the whole titration. So this is not adding a lot of volume. The data in your lab manual has much larger volumes for the titration. Maybe it makes it a little easier to follow. Okay, so that's basically number 1 on the calc. So what I did was all what's on the board is indexed to the calculation section in your manual or in your handout, whatever you're calling it. So it matches up exactly 1 through 7, okay? So I just try to keep it simple. So that's calculation number 1. We come back to from calculation number 4 later. Calculation number 2, now this, I'm gonna hold the data here because you might wanna like pause it. So here's the original data, and then you're doing a bunch of calculations to make what's called a first derivative plot. And that measures how fast does the pH change with volume. So if you've had calculus, this is change in pH over change in volume is ultimately what you want. But, and I'm not going to go through all of these in detail because the manual does this. So your delta volume is just subtracting the successive volumes here. So set up your Excel spreadsheet to do that. So it'd be like, I don't know, A3 minus A2, and then do the fill down, and it should do all of that for you. Please don't freeze this screen and type all that data. That's a waste of your time. Have the Excel do the spreadsheet, do the calculations for you. So you're doing delta V is 1. Your average volume is a little different. You're taking the successive volumes and dividing by 2. Again, follow the manual. It gives you an example there of how to do all these columns. But again, so it's this plus this divided by 2. Just make sure you put parentheses around that in the formula and have Excel fill all that data in for you. Then you do a change in pH, which is just the bigger pH minus the smaller pH in succession. And there isn't an entry here for the first columns because there's nothing before it. So the first entries for some of these. And then you take the delta pH divided by the delta V. So what? This column divided by this column. And that's what you get. So that's the data for number 2 to construct the first derivative plot. And number 3 is the first derivative plot. And what data do you use for that? Well, I just cut and paste the data. Now keep it, I put it onto a different worksheet on Excel. Keep in mind when you cut and paste, you may have to use that function paste special so that it pastes the values and not the formulas, because you may get a bunch of error messages here if you do that. And also you can adjust the decimal places on these. I made these 3 decimal places and these 2. So you can use, there's a feature there where you can adjust the decimal places. Okay, so what are you graphing? Well, you're putting the average volume, so the average volume, not the change in volume, on the x-axis, and the derivative, the change in pH divided by change in volume. Some of those numbers are really, really big. If you see that kind of has physical meaning, these big numbers up here. And it kind of looks like a peak. It goes up, and then it comes back down. And, oh yeah, and I should have said, you want to scale all these graphs. Take away all the dead space, like any unused space. Rescale the y-axis, rescale the x-axis. What else? Oh yeah, I put in these grid lines to help make readings later. These are, I think, called major and minor grid lines. You can add those, and again, cut away all the dead space that the Excel, and rescale the axes. Okay. Then what you do, and I'm not showing you all of this here because it's in the manual, is this is calculation number 3. The plot is part of it, but then you go through the procedure outline where you draw the curve up and the curve up, and you come down to the x-axis and figure out the volume of the equivalence point. Now that's the volume of NaOH required to reach the equivalence point, which means where all of the acetic acid has been neutralized, it's been reacted. So I'm not going to do that on here. There's an example in your manual, and you go ahead and do that. Okay, and then the last step that you do in number 4 that's up there is, now that you have that volume, you know how much volume it takes, and I think if you can read it up there, I think the volume I did just eyeballing it, not that precise, I came up with 0.170 milliliters. So it's not very much. Then what you do for the last one, for number 4, you go back to the titration curve, put that volume from the previous one, go up and over, and get the pH at the equivalence point. Now, you're not using this pH to do any calculations. This is something you're going to use in one of the discussion questions. So that it won't carry over into anything else from here. This number will. This one is just for there. Okay. I think the next thing I want to do is come out from behind the camera. And we're just being safe here. Keep my mask on. And calculation number 6 has some parts to it. And I put a star next to it because I'm not going to do the sample calculation. I'm just going to kind of talk about it, and then you can set it up. So we back up here. Oh yeah, so we did it through number 4. Number 5, again, this is something I think you can figure out because we did similar things in the first semester lab. It says use the molarity and the volume of the NaOH to determine the moles of NaOH and the moles of HAC. Okay, so here's some sample data. Just assume that the molarity of the NaOH is 0.1 out to 4 sig pigs, and the volume is what I said before. Okay, so you should be able to get the moles of NaOH from that. if you look at the chemical equation of NaOH and acetic acid, which is in the manual, you can look at the ratio there and figure out how many moles of acetic acid are there in the sample. So you need a mole ratio. Again, go back to section 4.5 in your book if you need a refresher on titration calculations. We want to make sure you try to piece some of these pieces of the puzzle together. Okay, so that's number 5. Now number 6 has a little bit going in it. It says, considering the dilution you performed. What does that mean? Okay, well the dilution you did, you can go back and look at the procedure, if I remember right. Again, it's on you to remember all the details of the procedure. Is you took half a milliliter of kombucha and then diluted it to a total of 50 milliliters. Okay, so that's what that means. See you later. Just finishing up lab here. So you almost have to consider like a backwards dilution, if you will. Okay, so I'm going to let that kind of be on you to figure out what that means based on this. Okay. And then what does it say? Determine the pH of the undiluted kombucha sample. So the undiluted sample that you started with. Okay, so there's a little bit there that you're going to have to think about. And then you're doing an ice table analysis. And the ultimate goal of number 6 is to determine a pH. So we don't want to forget what the formula for pH is. pH is the minus logarithm log base 10 of the hydronium or proton H plus concentration. So you need a molarity there. So you need the molarity of H plus at equilibrium, so from an ice table, to do the calculation. And then question number 7 is calculate a relative percent error from your calculated value to your measured value with the pH meter. And I just made up a value for the measured one. So assume that you put a pH meter in the undiluted and you've got 3.18. So that may be a big error or a small error, I really don't know. Okay, so ice table analysis should be in your wheelhouse by now. And a lot of you probably already did acetic acid in lecture. I know with my folks we did, I'm pretty sure everybody does acetic acid as an example of an ice table. So remember what we're doing. Acetic acid is a weak acid in equilibrium with H plus and the acetate ion. We're just using the shorthand here. And you should be home free. Initial concentration, molarity. The change in the equilibrium concentration. So we're going to assume that those are zeros because they're initials. Your task is to figure out what to put there. See there? So a lot of the work is to figure out what concentration of acetic acid do you put here, and then you go through and you figure out your equilibriums and you solve using the system that you've done. In this case, I don't think you should try to apply the 5% rule. You probably can, and it probably works, but let's do the more precise method where if you need the quadratic equation, do that. So you solve for the equilibrium concentration of all species present, which is a pretty typical lecture problem. But what you really want is the H plus to calculate a pH, and then compare these two. And you should get something in this region. So if you calculate an answer, and kombucha is acidic, it's not super acidic, but it's somewhat acidic, so it should be a pH less than 7. And it's probably going to be less than 4. So if you get something in that region, you probably did it right. But if you do that for a pre-lab, your instructor will take a look at it, and if you did something wrong with your ice table analysis, that's something that can be cleaned up when you're in class with your instructor, or when you go and write it up. That's okay. You don't have to have 100% of the pre-lab done perfectly before you come into lab. But the more you have this worked out, as always, the more straightforward the procedure. And I think that's it. And then you've got some discussion questions And remember, don't lose the forest for the trees here. Kind of like the alcohol content, something you're going to draw a conclusion about. Does this kombucha fall within the acceptable parameters for what kombucha should be? In the alcohol lab, it was less than 0.5% volume percent to be legally sold. In this case, I don't think there's a legal measurement of acidity. I'm not sure about that. Vinegar, there is. But you want to measure it. Does it fall within this region? And I don't know exactly what kombucha we're using, but if it's from the company in Chambersburg, it still might be a production type of kombucha, so it might not be something ready for sale. And then we will go from there. And the last calculation is percent error. So you should know what percent error is. That's the measure of accuracy, and we're going to use the measured pH as our accepted or theoretical value. We have to choose one or the other. So you'll calculate a relative percent error from your calculated pH based on your measured pH. I think that should be pretty straightforward. Okay, that's it, folks. Make sure you watch the pH meter video as well, and get as far as you can with the pre-lab questions. All this Excel work, if it's pretty straightforward by now, I think we've done a ton of Excel work this semester, which is awesome. And that's it. We'll see you in lab.